Hi, everyone. Good afternoon, good late afternoon, and thank you for coming for this session. I hope I won't keep you so long. I mean, this is the last one. A lot of people leaving. My name is Jack Zhang. I used to work with the famous Intel NSG group, SSD group, and also Optin as well. These days, my job is going forward with a lot of software side. And also Jian Zhang, he managed a group. Basically, this piece of those work are mainly from their team, not me. I'm in Folsom. They're in PRC. They used to work a lot, contribute a lot on staff and Lustre, those storage things. And these days, they're working on the storage for AI and also AI optimization. Today's topic is what we want trying to do is make easy, cheaper AI solution end-to-end. We call that democratization. So today's topic is on the AI data democratization end-to-end. So little background on this. People understand that AI is very popular, key important for business these days. Vehicle driving, blockchain, natural language processing, virtual reality, a lot of things. Let's look at this. This chart is just make a simple drawing to AI end-to-end is very complex. We're trying to make a simple, those three major position, the stage, but each stage have a lot of things. First, you got data from various source, and you need to ingest data to data process, cleaning, ETL stands for extract, transfer, and loading, and load, and feature engineering. Those are data processing. Majority of those things are handled on the data lake, Spark, those very cheap S3 interface data storage. Middle is you got the data, you train the data, do training, build a model, and this involved a lot of iterative process. Each state going to be repeat several times, many times. Training, retune, back the data, clean the data again, and move to the analytic environment and doing the model building. And then you need to serve the model to go to the production environment to serve the customers. Those three stage involve a lot of complexity, and machine learning code is just small part of real world AI system. And vast majority of complex pipeline infrastructure is needed for this AI. And we see the challenge. We see the AI work, AI training, build a model is more for the higher, top CSPs. A lot of people won't able to do that. The challenge is, if you look at this, I put a software stack on each stage. Basically we have three: data processing, model build, development, and serving, right? The data processing, we have Kafka, we have Spark, we do NIFI, and for the 60%, a lot of data growing very fast. The data set is getting bigger and bigger. So you won't be able to just I'll talk that in next slide. You won't able locally, you have to build a distributed storage system and suitable for this AI model building. And then you have all the unstructured data. You need a Spark, Panda, NumPy, those are going to be, that's really the work to process the data, to clean the data, to fill the empty, missing data, and then to parse, to attach, to augment. Those are currently is implemented, did by a data scientist. That's it's really hard for them to use the Spark, those software package. And also this take them like 40% of their AI time. And then for the model development, those are typical TF, TensorFlow, PyTorch. That's all very complicated. Use a lot of computation, use a very intensive computation. Very expensive. That's a GPU, a lot of GPU play well on this. I mean, NVIDIA, everybody knows, play very well in this area. And then serving, you got first deploy the model, deploy, and then on the cloud, and let people serving the people, serve the inference. These actually, the first one and last one actually is not really GPU related. It's CPU and other. It's going to be built very cheap stuff. And overall, we see the challenge. This is not, AI is not just, it's high cost, and it's a lot of people, all of position, role, and high skill set involved, like product manager, data scientists, developers, and operating. You need to keep monitor, virtualize your infer model, and feedback the data. If it's not that accurate enough, you got to go back to look at the data. I mean, to add more data or reduce data, you have to go back to processing data again, and then you build a model and tune. That's basically a very challenging part. So the motivation for our democratization, actually not, this is industrial, like large CFC, AWS, they have their recognition model. They build and they publish on the website. You can, using their already built model, you put your input and get your result to make service. That's one of the big trend. But they never publish inside. But when we look at this, we want to build end-to-end AI democratization. First, we want a unified data platform for data analysis, right? Training, inference, pipeline. Inside you, data processing, training. Best way, if we can, one cluster to get those data analysis, build a model, and then serving the customer will be super perfect, nice. But the reality is you have different system. But we want to build as much as a unified data platform for everything. And simplify the model development, the optimization, right? Building high-performance model, right? Using as much as you can auto machine learning, AutoML, and those automatic network construction. We call this neural architecture search, which is really, really hard, really compute intensive work. And I'll show that too. And I also show what we did for that. And then bring the end-to-end. Basically, if you want, everybody can play and use it. One thing is like the cloud, right? Cloud is better. And also behind the cloud, we want a cheaper or at least commodity hardware. So those are, so when we're talking about AI democratization, the goal is very simple. We want everybody can do AI accessible. AI can be accessible and affordable, especially for those Enterprise customers for the business, small business who does not have a lot of engineering developers on AI, because AI involved from front to the end. There's a lot of high skill expert needed and very cost. So we want accessible, affordable. So first, the AI not just restricted to data scientists. We want to be a citizen. That's why we call it democratization. Expand to the citizen data science user. And second, we want very commodity hardware. So we want to make it faster. So enable and scale up and scale out the optimized framework and toolkit. We developed a toolkit. I will show you as well. For the make AI easier, we want automatic. We don't want manual training. We don't want to look at the thousands of parameters. We want something close. Of course, manual always can get better tuning. We want something like automatic network constructor to help you to simplify the training, and especially feature engineering. I'll talk a little bit about the feature engineering as well. And then we want something like pluggable components and connect to the third-party ML solution platform. Lastly, we want making AI accessible. That's very obviously, right? We want a very commodity CPU, Ethernet, GPU as well. I mean, very commodity, not very expensive one. So what actually we want to democratize? First, look at the flow chart of AI, right? The first thing is data accessibility and the quality, right? We want democratized, we want to use data management, data injection, data warehouse, data lake, going to be explored, visualized, and processing. We will have example for that. And story and compute platform, we want a scalable infrastructure on commodity hardware. Now, GPU, CPU, okay, but we want something very common, everybody can accept the cost. Then algorithm is more important. Currently, GPU can do a lot of good work. It's because we are not doing much optimization on the algorithm. They run faster than CPUs. Of course, that's because the flops, right? The faster flops. But I'll show you example, if we do algorithm optimization, we can get much closer to GPU on some workload, right? Not everything. So that's also the purpose to reduce the cost, right? The model development, we want end-to-end model development, training, and deployment. Basically, we want a pipeline. We don't want a single, during that pipeline, we don't want a single bottleneck, because single bottleneck can get your cost, get your long time for building the model. In the marketplace, we want to democratize the use, exchange, and everybody can use this. And then we'll talk about from case study to actually data platform. We first look at before we tap into the details, we want to look at the data, right? Data is first thing coming to it's the start of AI model building, data processing. The data set, it's a lot of workload. Here I use a recommendation system, right? The typical very high, those are four, right? The DLRM, the DIEN, the WD, and also rack system are very popular, right, these days from the large top one CSPs. And if we keep an eye look at those recommendation system like fitness tracking data set, review data, social data, whatever the data, geographic data like Google, local. They all have common features. They all user item interactions, star rating, time steps. They all put into tabular format. You have multiple columns with millions of rows, that kind of thing. So if you look at those, it's not that complicated, except it's big, like up to a terabyte. So basically, we understand that the data set can be similar and common characters, so we can, based on that, to develop our API to do data processing. After data set characters, we want to look at the process of how we process those data. Basically, you have feature engineering. Basically, what feature engineering does is they load the data, they look at data, fill missing data, short augment data, you split data, figure out the data, the relationship between data 1 and data 2, and that's some like virtual face recognition. They label all the location, geographic stuff. They label the hotspot. That's the feature engineering. It can be extended. Actually, they all crossed, like feature engineering, data pre-processing. They cross, people talking. Sometimes they miss them. So the other data processing, you convert, you convert and transform your data. One example is the model, the machine learning, deep learning model building platform only accept numerical data, not geographic, not categorical data. So you have to do some format of the encoding to convert that categorical data to numerical data. That's all. It's just, I just saying a little bit. So this is just, we're just showing this one process. Actually, when your data is not accurate enough, you have to go back and reprocess again. So this, if we want faster, efficient data processing, we want a parallel instead of a single thread, single processing. The current like DLRM, DLRM, and DIEN, and the NumPy, they're all doing the simple one thread, one process. So that's the processing. And then data connector. So basically, when I mentioned large data set, your data actually, when they're talking about the large data model, AI model building, large data set, typically your data cannot be local. That's the data. Your data is going to be on a big data cluster, HDFS, Hadoop, Kafka, whatever, those distributed storage stay there. And you do data analysis there using Spark. And then you have to move the data. The data set is big, and there's involved millions, billions of files, right? And then you have to move those data to fetching enough data for GPU to do training, to do building their model, and then back and forth, right? Then single GPU for that kind of large distributed data, one single GPU won't work. It's going to be multiple GPUs. That's we call it AI cluster, distributed training cluster, and that needs aggregate I/O bandwidth to achieve that. So that's another reason we have to do parallel system instead of single. Like the NumPy and DLRM, those systems just doing a single process one by one. And also the challenge, right? The cluster separate CPU for data analysis, because nobody uses GPU for data analysis. It's too expensive, and GPU for training. And then you have to move data back and forth. And software complexity as well. And feature store. I talk about the feature engineering. So you mark data, you truncate data, you convert data. But that's every AI product involves this, and this handled by different team, and different team building different AI model. That is kind of repeated work. Many of the works is, look at this very simple, I'm not talking to you. So we use a feature store, meaning you can use MySQL database to get the build up existing, you save those feature somewhere, and people can leverage your the feature, the way you cleaning the data, the way you mark the data. So that's a feature store. So feature engineering can first look at the feature store database and get those feature marked for training, before the training. You don't need to go raw data, shuffle, you don't need to start from scratch. That's the one we see is everywhere these days. Can bridge data engineering and data science to simplify the feature engineering process. And then model democratization is another one. So as the AI requirement, I mean, we call that parameterized deep learning model size getting bigger. The chart, if you look at the chart on the right, top right, that's the model growth. We use NVIDIA V100. You see the model parameter getting larger and larger every year, 10 times, 8 to 10 times. And model flops you need 10 times. While the GPU, we're just using NVIDIA, the hardware itself won't consume that. It's like the growth for the flops is just 5 times, maybe less than that. So in order to meet those over-parametered DL model, you need a super compute intensive model. And this model is hard to deployed in the current resource constrained environment. Basically, what the industry does is leverage the distributed training system, which you just adding more GPUs, right? This can be we think this can be solved by some like we said, optimization technology, like compression, right? Like reduce the layer, and also learning technology, automation, right? The things you can train faster instead of human being involved is better. You train and get scored and coming back and train again, right? If it's all automatic, it's going to be good. So automation for HPO. HPO stands for hyper-parameter optimization. NAS stands for neural architecture search. Those are very super cost for your training. Then efficiency architecture, right? Also infrastructure, the hardware infrastructure. Your hardware developed close and help those training model building framework. Like here I mentioned 2 things like Intel IPX and ITX. Those are 2 extension for PyTorch and TensorFlow. What it does is like they modify the instruction and suitable for those PyTorch and test floor. So in summary, this optimization, data process, feature engineering, not just one. If single one got bottleneck, got not enough efficiency, they're going to get whole pipeline inefficient. So we need a coherent optimization, right? Data processing framework. Basically, you do parallel data processing, modding, and also Spark with OAP. OAP stands for optimized analytic package, which is on top of the Spark, Intel. It's a free. It's open source. Optimized of the Spark. Instead of a Spark single thread, this is multiple process, multiple parallel process. RecDP, well, I'll touch that later. That's our developed kit for recommendation system, deep data processing. Much more. Distributed training, right? I mentioned Intel, IPX, and ITAX. You can Google that, see if you don't know that. By leveraging those, got your algorithm optimized on your platform hardware, getting training and enhancement. Right? Now this is not just this is the industrial proposed data platform for AI architecture. From the lower level, right? You're using commodity hardware, CPU, GPU, FPGA, and on the top you Kubernetes. You use Ray and MLOps software framework, and on top is your flow for the data processing. Basically the storage file system, the HDFS S3+. That's your data lake, your data stay. Whatever the data you grab and put there, and then you need a data management. You need a Spark and the modding to manage processing those data, to build the right data, clean data, high quality data for AI model building. Those are we call processing and data management. That's also including feature engineering, right? And then we have data connector, so we can connect those to get those processed data back to the AI cluster, training cluster. I intended to mention, I'm not mention all about those, but I'm trying to highlight data processing. We got one module, and data connector, data advisor, and data constructor. I'll talk that in details about those. What the data connector is, connect the data from distributed storage, your training data, your pre-processed data to AI training cluster. And model advisor is kind of intelligent model optimization. So when the data coming, you know what going to be do, and you reduce the training time. And also there's some limited, like AWS, they already built a model for you, and you just using that model and try your service or in your service environment and see the accuracy is not enough. Then you go back and put more parameter into that model. They build another one. This is the same thing, model advisor. And the model constructor is, remember I talked about NAS, neural architecture search. So those neurals also need training before. I'll talk about a little bit more on that. It's take super long time. You never can be end by that. So we have some optimized constructor to solve that problem too. Lastly, I want to briefing FI talk about Intel end-to-end optimization kit. So basically, based on those AI democratization idea, we want to build first composable framework for AI democratization, both on data processing, training, and inference. Right? Deliver higher performance, lightweight networks and models. Right? What we does, if you look at the chart here, I'm not reading, we first built this product on the recommendation system. We're going to continue working on different AI workload. The recommendation system, basically we have parallel scale data processing, which is RAG DP data processing, right? Recommendation system data processing. And then we have a model advisor, we have a network constructor, and then democratization models. Then I'll talk one by one. Okay. But those are all, if you see the bottom, we put in the GitHub. What the data I'm showing here, if you're interested, you can repeat those results. So the recommendation data processing is it's basically we have a Python API, so it's easy to connect to this. The data scientists can easy to use it for data cleaning, data processing. So we have on the bottom we have Spark and Modi. So basically, this is on top of the Spark and Modi. You convert the categorical data, you transform data, optimize, you join and split those. Especially for the filter. Filter is one of the things you're missing the data, you have to fill that. That's the algorithm we developed to help this. And also I think there's a couple of features, easy to use, optimized performance, right? Although the feature engineers, we have that targeted encoding. It's one of the optimized feature for user-defined functions. And data connector. So on the right side, you can look at distributed storage, data processing on that distributed storage, and feed to the training cluster, training environment. For deep learning framework, TensorFlow, so PyTorch, Central, need a parallel. What we did here is based on we optimized called Pattern Store. Pattern Store is a Uber open source parallel processing framework. It can be directly write to the HDFS. But we optimize a couple of things, enhancement, we call it. One is in raw data loader extension to the currently DLRM binary loader. And we implement, I think this is something I remember correctly, if I'm not wrong, is per key of, the current issue for that Pattern Store, they have imbalanced data size, so that caused a delay. We have consistent bench size across the ranks. And the model advisor is one thing to help. We built got a smart democratization advisor SDA on top of the SIGOP. SIGOP is basically we can. This is user guided to facilitate the SIGOP based on parameterized model. So it generates SIGOP YAML file based on user choice. So you can choose which one, what parameter you want and tune. And we provide building intelligence through parameterized models, right? Those models. So input is same thing, data set, feature shapes, model, parameters. And output COP is got a YAM file, and plus the target numerical feature column things. This can be extensible to integrate other tools, right? The other one thing, so basically this is, when you build this, you can do a single line process to build model. At the bottom, they said there's the run AIO key file, which is you got a data path and you can build a model, just automatic, we call it AutoML. And the last one is smart network constructor. As I mentioned, when you do NAS, in order to build, you got to have training, right? The NAS has extremely computation intensive, right? And GPU, even GPU. So the time of the NAS search is basically M times N T, which is your candidate's life, and also the candidate evaluation time. That's huge. If you look at the top right chart, you can see with the CPU days, GPU days of this kind of searching can be, without the optimization, it gotta be 10 to even the thousands of days. That's impossible for this training. So what we have is proxy performance predictor. This is one technology.
Here's what I found.
Sure. No, sorry. So zero cost proxy performance. So basically, instead of training, we use the scored candidate network rather than training. So based on the score, you assume you're matching score with the training result. So the performance, what do we have for the rack system end-to-end democracy? We have, remember we said parallel processing. We talk about the single node baseline versus full node democratized 4-node AI system versus single node. As you can see, this end-to-end democratization deliver like 30 times based on ETL training time, right? Speed up compared to the single node baseline, and also got 150 times and 17 times and almost 9 times inference throughput speed up for the compared to DLRM and WIN and DIEN, right? The key contribution for those are actually, as I mentioned, scale out data processing, Spark, replace single thread, right? Python data processing, interoperable training framework, Apex, and TF, BF16 light model. And the other performance we compare with the GPU. This is a DLRM performance. GPU V100 versus 4 CPU nodes. Right? As you can see, there's enhanced scalable hyper parameter tuning with SDA. You can get for the single SDA versus the GPU. It got very close. And then compared to the original DLRM, we got 5 times better. And also, if you look at the SIGOP itself, without this SDA, you get 5 times better with 5 experiments. Right? There's all those results can be shared and be see on our GitHub website. Okay, summary. Basically, end-to-end complex. And then AI is very complex, right? We need a different way to manage and to overcome those challenges. A unified data platform can be optimized for the end-to-end AI and improve performance and reduce costs. Right? That's the democratization. So the AI democratization is going to make AI accessible and affordable. Currently, we're doing the end-to-end AI optimization kit for the recommendation system. The current very early result shows very promising result, right? Compared to GPU, compared to the without optimized like DLRM SIGOP result, right? And then we are working on different workload like computer vision, neural language processing, right? And automatic speech recognition. We want to simplify those things using the AI democratization. And then the last is the GitHub there. You can go there. Welcome to see and give us questions or feedback. We're looking forward to help those who wants AI but who don't have a capability. We don't want to spend too much cost on that. I mean, enterprise, tier 2, yeah. Everything's open. Yeah, with that, I think I talked too much. Any questions, feedback? I mean, I know this is kind of a little bit different from storage, but they all involved from AI, from your data processing involved storage to processing, right? We're also building some optimized data storage for AI. Actually, AI data processing. All that storage for AI storage, for processing. For actually your training, most of the data should be in your memory, right? Yep. Thank you so much. I mean, I'll take questions.
Just a question. Are those available also for the academic community or just for enterprises?
I think this is open for everybody.
Okay.
Yeah, and this GitHub thing, and it's very early stage. I mean, we show the good performance. We love to get a couple of customers who has their real AI problems. We can work and test this as well. It's good for us and good for customers as well. I'm done, almost. I don't want to let people stay here forever. I want them to go to bar. Yeah. Just one question. Yeah. Yeah, please.
Can you move that to slide number 17?
Yep, this process.
So, I was wondering that if the hardware is changing, so even though the hardware like CPU and PCA,
Mm-hmm.
so do you think that you can still keep the same data platform even though you use the GPU and PCA other than CPU?
The question was, can I use the CPU, GPU, FPGA as a commodity platform? Is that right? Kind of hear the first couple. Yeah, we're trying to get the commodity hardware platform, right? GPU for CPU. For data. The best way I think is if you can get everything in one cluster. You don't need that's not reality, right? You processing data. Data is available for that GPU or the training model build development. That's perfect. But when the data set is getting larger and larger, you probably want you have something like CPU handle the distributed storage, right? And also CPU can handle the one of the test results is showing that on some workload, with SDA, my CPU, 4-node CPU can compete with V100, and my cost is cheaper. So on some workload, we can do. So the CPU is very commodity hardware, and also FPGA. So we want that. Yeah.
So in the performance comparison,
Mm-hmm.
so you are assuming that only CPUs, four CPUs,
Yeah.
and then you use V100. So that's so you're running the data platform on CPUs and CPUs.
Yeah, basically you have like a CPU cluster. This case, 4-node CPU cluster, and compete with the V100 on the same model build development. Training time, actually. Training time. The one thing I have to mention a little bit is like GPU usually they are not doing optimization of your data set, right? And with my developer kit, there's called SDA. I don't know you heard that. It's called advisor. So basically, we tune those parameters to best fit to the training. That helped a lot. But I think with that, I mean, if you can optimize your algorithm and doing that SDA kind of thing, I think to reduce your cost and put your training on commodity hardware, I think it's worth for that. And everybody can use that instead of buying GPUs, right? Good question. Thank you. Okay. I think 5:25, exactly the time. I appreciate your time. And, forget the last one. They always ask me to do this. Yeah, take a moment to rate the session. Like or not like it, that's fine, but we want some input. Thank you, appreciate it, and you guys have a good day. Thank you.